This is a lesson on scalar multiples of vectors and parallel vectors in 2 dimensions. Suppose this is vector A, and we are to find, say, vector 2A and vector negative 3A. Vector 2A will just be a vector that is 2 times the length of A and in the same direction as A. So if that's our vector A, then 2A, the length of A in this case is 2, so 2A will just be 4, and then it will be in the same direction. So this is vector 2A. Vector 3A, on the other hand, will be the vector whose length is 3 times A and in the opposite direction. So it will have a length of 6, but the direction is here. So that's vector negative 3A. The numbers 2 and negative 3 here are called scalar multipliers, and 2A and negative 3A are called scalar multiples of the vector A. To get the scalar multiple of a vector in component form or in unit vector form, we simply multiply the components, each of the components by the scalar multiplier. So for example, if we have the vector A, whose components are 5, negative 3, for example, the vector, if our scalar multiplier is 3 and we want to get 3A, we simply write it this way: 3 times 5, negative 3, then multiply each component by the scalar multiplier. So the result will be 3 times 5, which is 15. 3 times negative 3 is negative 9. Similarly, if the vector is in unit vector form, say B is, say, 4i plus 2j, and we want to multiply it by the scalar, say, negative 2. So we want to get negative 2b. That will just be negative 2, and then, it's negative 2 sort of times 4i plus 2j, which is negative 8i minus 2j. Vectors on the same plane are parallel if they do not intersect. From a vector process perspective, if, say, this is vector A and this is vector B, they do not intersect. A and B will not intersect, and therefore parallel if one is a scalar multiple of the other. So I'll write that down. A and B, or A is parallel to B if one is a scalar multiple of the other. We can write this definition in symbol form this way. If A is parallel to B, then there exists a scalar K such that A is equal to KB. That's how we write A is a scalar multiple of B, and the scalar is K, or B is equal to Ka. Suppose we have this problem. If A has components 2x and B has negative 4, negative 3, find x if A and B are parallel. So we start with if A and B are parallel, then we could express each as a multiple of the other. So we could either say A is equal to some scalar k times B, or B is equal to Ka. It doesn't matter which one you use. So if we use this, it means that 2x is equal to, we don't know what k is, we will figure it out from the given information. So now you could write the right-hand side as negative 4k, negative 3k. If the vectors are equal, the vector on the left equals the vector on the right, then we could equate their components. So 2 must be equal to negative 4k, and that gives you k equals negative 1/2. So now x must be equal to negative 3k, and because k is negative 1/2, x will be negative 3 times negative 1/2, which is positive 3/2.